As a math major, it's important to understand the origin of mathematical concepts. One I recently learned myself was a geometrical interpretation of a complex number. In schools, we're simply taught to memorize the fact that the square root of -1 is equal to I, which is an imaginary number. But what does that look like in a geometric sense? In order to understand what a complex number is, we must first understand the origin of 3 fundamental rules in mathematics. For the sake of simplicity here, we will just use one exclusively in these rules. A positive times a positive gives you positive. A positive times a negative gives you a negative. And a negative times a negative gives you a positive. Drawn on a number line, we have -1, 0, and 1, as shown, equating +1 to 0 degrees, and then -1 to 180 degrees. The degrees here are the important components that allow us to prove these 3 equations. So since -1 equals 180 degrees, our -1 times -1 equals 180 degrees plus 180 degrees. This is going to give us 360 degrees, which is also equal to 0 degrees. And we know that 0 degrees is going to equal our +1. And by the same principle, we can prove the other 2 equations, as shown. So now knowing this, what is I equals the square root of -1 really mean? Well, we know that I squared is equal to -1, or I times I is equal to -1. And since we now know that -1 is equal to 180 degrees, we can only assume that each I is equal to 90 degrees respectively. So in terms of the number line from earlier, with an added y-axis, our points of 1 and -1 now become vectors, ending on points 1, 0 and -1, 0 respectively. Knowing now that I has an angle value of 90 degrees, we can plot I as a vector on our axis, ending at point 0, 1. It's important to note that traditional numbers represented on this plane will always have a 0 y-coordinate. You could even go as far as saying that the x component is going to be your real component, and your y component the imaginary component. With this knowledge, we are now able to plot any complex vector solution of the form a plus bi, where a always represents the real part and bi the imaginary part. On our same xy plane, this is how you would show the vector a plus bi, with points a and bi. Complex numbers occur very naturally in quantum physics, but are also very useful for modeling periodic and sinusoidal motions, like water or light waves. With all of the immense applications, taking a step back and looking at the origins of math concepts reminds us of the true beauty that mathematics holds.